Hi, in this video I am going to explain the implementation of random forest classifier. Random forest classifier is an ensemble learning method that can combine multiple decision tree to make prediction. It randomly selects subset of feature and data points, build decision tree on them. Now we can see the example. First, import Panda, NumPy and Seaborn and Matplotlib libraries. Here, data manipulation for pandas and NumPy, visualization for Seaborn and Matplotlib, and analyzers. Here, import train test split from sklearn.model selection. And then import classification report from sklearn.metrics. And then accuracy score dot import accuracy score from sklearn.metrics, and then confusion matrix from sklearn.metrics. This line imports specific classes from the sklearn library for model evaluation and performance metrics. Here we use the iris dataset and reading the dataset using read CSV function. Here I copy the path and just paste this to read the dataset. First import the libraries and read the dataset, and using head function to know the first 5 rows of our dataset. This is the first 5 rows, and using tail function to know the last 5 rows of our dataset, and snl function return a boolean data frame indicating whether each value is missing or not, and data.describe function used for statistical measures. And then here this line select all rows and all columns except the last one from the dataset data using integer based indexing. The selected values are assigned to the variable x, and then select all rows from the dataset data and only the last column uses the integer based indexing. The selected values are assigned to the variable y, representing the target variable. X is the features variable and y is the target variable here. By running this code, the datasets are imported. Now we splitting the data into training and test. Split the feature variable x and target variable y into training and testing dataset. The train test split function from sklearn.model selection is used for this purpose. It randomly shuffles the data and assign 80% of the training set and 20% to the testing set from x test and y test. For x and y, a random state equal to 0. By importing this, the data sets are trained and tested successfully. Now importing the minimum max scalar from sklearn.preprocessing to normalize the feature variable. Minimax scalar here minimax scalar function is used and stores in a scalar named, and the scalar is fitted on the training data using the fit transform method, which calculate the scaling parameter and apply the scaling simultaneously. Xtrain and The same scaling parameter are then applied to the testing set data X test using the transform method. By running this code, these codes are successfully imported. Now we implementing the random forest classifier from sklan. Import the random forest classifier from sklan dot ensemble. Random forest classifier and create an instance of the classifier name model. The max depth parameter is set to 2, limiting the depth of each decision tree in the random forest. The classifier is then fitted on the training data X train and Y train using the fit method. Finally, the trained model predicts the target variable for the testing data and assigns the prediction to Y prediction using prediction function here. By printing the Y prediction, we know the prediction of this model. Using predict function here and run this code. Now we print the Y prediction. Here is a prediction for our model. Print your classification report based on the predicted target variable Y prediction and the actual target value Y test. The classification report function from sklan.metrics calculate and display metrics such as precision, recall, F1 score and support for each class and the classification problem. And this line prints a confusion matrix based on the predicted target value and actual target value. The confusion matrix function from sklan.metrics create a matrix that shows a count of true positive, false positive, true negative and false negative prediction for each class. And the last line prints the accuracy score of the model prediction. The accuracy score function from sklan.metrics compare the predicted target values with the actual target value Y test from Y prediction and return the accuracy, which is a ratio of correctly classified samples to the total number of samples. The result is printed with this string accuracy is concatenated before the accuracy score. By running this code, our accuracy is 1.0. It means our accuracy score is 100%. Our accuracy score is 100%. And then here we pre-processing the data and then splitting the data and then implementing the data set. Thank you.